All right, ladies, let's review concepts learned for writing an equation for a line. So writing an equation for a line. Okay, so when I'm writing an equation for a line, essentially I'm writing a formula that describes all the points that exist in my graph. Okay, so for instance, imagine I had a graph and it looked a little bit something like, I don't know, this. And I wanted to write a formula that described all the possible solutions of the points that exist on this line. All right, so how can I do that? Well, what's interesting is that formulas have a pattern to them. And the formula for any line is going to examine the rate, which we call the slope, and it's represented by the letter m, plus whatever your y-intercept value is. It's kind of like your initial value. If you can identify these two key concepts, you can write a formula for all the points that exist in this line. All right, so let's see if we can do that. Slope represents the change in your y over the change in your x. So if I identify 2 points that exist on my line, I can count the change vertically divided by the change horizontally, and I'll be able to figure out what the slope is. All right, so let's see. Up 1, 2, 3, and then to the right 1. That's telling me that the change in my y value is 3, the change in my x value is 1, so I have a slope that's equivalent to 3. And now my b value represents the y-intercept. It's kind of like your initial value. If I want to find the y-intercept, I look on the y-axis and I identify the point where the line intersects the y-axis. And that location is at -4. So when I go to write my equation, I fill in my m and my b with the values I just calculated. So here, this is 3x minus 4. What this is essentially telling me is that if I choose any point on this line, it should work in this equation. Okay, so let's choose a point that exists on the line and see if that is correct, if that statement is correct. So if I look to the left one, I'm getting out -7. So what I'm going to do is I'm going to insert into this equation the number -1 and check to see if my formula is correct. All right, let's see. 3 times -1 is -3, and -3 minus 4 is indeed -7. My formula works for every single point that exists in that line. All right, so that is one strategy for writing an equation for a line. But what happens if you don't have a graph? Okay, so what if they give you something like this? They tell you that there is a point on your graph that passes through the value -3, -4, and has a slope of 6. Okay, so imagine that scenario. You can kind of think about where that location is. It's left 3, down 4, and it has a slope of 6, so it's kind of steep, right? Without a graph, it's going to be difficult for me to identify the second part that I need to write my equation. Remember, my equation is y equals mx plus b. I know the m, but I don't know what b is. So I need a new strategy. And the strategy we use is something called point slope form. Or point slope equation. And this is that formula that you can use to derive your b value. It's y minus y1 equals m times x minus x1, where the y1 and the x1 represent the location of one of your points that exist on that line, and m obviously is your slope. All right, so here, let's do it. We have y minus our y value of that point. That's -4. Okay, so y minus -4 equals my slope, which is 6, times x minus my x value, which is -3. And I'm going to simplify this equation. A minus minus is a plus. Again, a minus minus is a plus. And now what I can do is I can distribute and balance. Distribute y plus 4 equals 6x plus 18. And I can balance my equation. And now look what I've done. I've developed a formula in slope-intercept form that should model this piece of information. All right, let's look at our graph again. If I were to continue upward, what this is telling me is that eventually my line will intersect my y-axis at the value of 14 and continue having a slope of 6. So this is a strategy to use when you're given two pieces of information, a point and a slope, and you're asked to write the equation that models the line. All right, one more example, and I think you guys will be in a really good place for this. So the last example I want to look at is something where you're going to have two components, two values. Okay, so imagine for a moment that I gave you the points 4, 0 and 8, -2. And I asked you to create a line that passes through these points. All right, so you have 4, 0 and at 8, -2, so over 8 down 2, and I'm trying to create a line that passes through those points, okay? And I'm writing the equation that is developed by that. Okay, so let's see what's going on. In order to write the equation for a line, I need a slope and I need a y-intercept. Okay, so I need a slope and I need a y-intercept. I don't have either in this problem, so I'm going to calculate the slope using the formula y2 minus y1 over x2 minus x1. All right, so this is my first point, this is my second point, so this is my x1, this is my y1, this is my x2, this is my y2, and I'm going to substitute these values into this equation. So I have -2 minus 0 over 8 minus 4. I'm getting -2 over +4, which simplifies to a -1/2 slope. Okay, now I have my m, I need to derive my b. How do I do that? Point slope. All right, so we got y minus y1 equals m times x minus x1. I'm going to substitute in my slope, which is -1/2, and I'm going to go back to my problem. I'm going to choose my x1 and y1, and I'm going to substitute that into the formula. All right, so we got y minus my y1 value, which is 0, and then x minus my x value, which is 4. And so I have y equals -1/2 x, distribute the 1/2 plus 2. And there's my formula that will describe this line. All right, I hope that helps, girls. Have a good one.